Thursday. I'm next weather meteorologist Lisette Gonzalez, and we do have a level 1 risk of flash flooding today. This is from the Weather Prediction Center for Broward and Miami-Dade County. On top of that, a coastal flood advisory continues through this evening.
The Florida coast had always seemed like a place of sunlit calm, palm fronds swaying in gentle breezes, and waves advancing in predictable rhythms. But early one morning, without any prior warning, something changed. Something strange and unsettling. Along stretches of shoreline from the Panhandle down to the Keys, witnesses began reporting bizarre disturbances in the water and along the dunes. The sea's surface shimmered in odd patterns, water levels flickered up and down in small pockets, strange hums could be heard at twilight, and patches of foam or churning currents appeared where none should be. These anomalies erupted almost simultaneously across a vast coastal area, and nobody saw them coming. Before we start, smash the like and subscribe buttons for more updates. The first signs were subtle. Fishermen in the Gulf waters noticed that their lines tugged with a peculiar tug-and-release motion, as if some unseen mass below the surface was flexing and receding. In the shallower inlets, swimmers swore they felt a gentle lift, a suction downward, only to be jolted back up a moment later. The horizon itself seemed to shimmer with heat or distortion, though the air remained cool and steady. Along dunes and near mangroves, sheets of mist rolled inland for brief instants before vanishing as though sucked back into the sea. Towering birds roosting near the shore were startled. Some took flight in waves, then settled back down, as if they too sensed the change. Marine radar and sonar systems, often employed by local Coast Guard and scientific patrols, suddenly registered odd echoes. Where once the undersea continent slope gave blank space, tiny blips appeared. Clusters of moving echoes that didn't conform to known species or schools of fish. In certain zones, the seafloor map readings flickered, suggesting shifting terrain or an uneven mass rising. In one case, a coastal research vessel reported that for several minutes, their depth gauge fluctuated wildly, as though the ocean bottom had undulated beneath them. Their instruments also picked up electromagnetic disturbances. Devices calibrated to monitor magnetic field orientation showed random perturbations, small but outside of expected variation. Navigation systems occasionally showed momentary compass jumps of a few degrees, a curious but alarming twist. What made all of this unnerving was the absence of precedent. In decades of coastal monitoring, nothing remotely like this had been recorded. No hurricanes, no underwater earthquakes, no storm surges, no dredging projects or man-made blasters had been scheduled in the area. And yet the event unfolded in silence across hundreds of miles. Locals who had lived by those shores for generations compared it to nothing. They invoked old fishermen's tales, whispered legends, and uneasy omens. Social media lit up with amateur videos, shimmering lens flares over the water, rippling columns of mist, waves that flickered in odd lattice patterns, and sudden disturbances in otherwise calm swells. The videos showed polygons of foaming water, large cracks in the sea's surface like broken glass, and arcs of electricity-like light shimmering just beneath the surface, then vanishing. Whether lenses were deceiving or real, the coincidence of so many similar reports across distant communities added weight to the spectacle. What could possibly be happening? The implications grew more chilling by the hour. One possibility is a massive subterranean shift, perhaps a fault line or underwater ridge that had quietly begun to move. If the continental shelf or an undersea escarpment were slipping, even by mere meters, massive energy could be unleashed into the water above. Such a shift might create pressure waves, magnetic anomalies, and distortions of water flow, all of which might manifest precisely in the weird way these witnesses described. Yet no conventional seismic stations registered a quake strong enough to explain this. No local geophysical observatory posted alerts. If it were an underwater geological event, it was a slow, stealthy one. Something not triggering conventional thresholds, but enough to ripple through coastal waters. Another possibility is gas or fluid release from beneath the sea floor. Methane or other volatile gases can accumulate in sedimentary pockets, and if a pocket ruptures, bubbles could burst upward through seabed strata, displacing water and creating transient upward currents or localized pressure shifts. If gases force their way through faults or fissures, they might carry along sediment, causing turbidity plumes that scatter sonar returns and distort radar reflections. A massive degassing event might also produce pressure differences that could tug subtly on the surface, even produce audible hums or rumbles as gas under pressure streams upward. But for such a phenomenon to occur simultaneously over many miles, the gas reservoir would have to be astonishingly vast or interconnected far beyond known capacities in that region. Then there is the possibility of a hitherto unknown geological or physical phenomenon, something not cataloged in standard Earth sciences. Perhaps a shifting layer deep below the crust, one that momentarily altered the gravitational or magnetic gradient over a swath of coastline. Such a phenomenon might manifest as minute but detectable electromagnetic fluctuations and might disrupt the interface between water and air in a way that causes shimmering or rippling distortions. If such an event is possible, and the Florida coast is no stranger to ancient carbonate foundations and subterranean aquifers, it raises questions about the stability of the coastal geology. Could an unseen cavern collapse, or could lava or magma intrusion, even rare in Florida's geological history, be at play? While conventional science deems Florida nearly free of volcanic risk, legends of a so-called swamp volcano have long circulated in local lore, though lacking hard evidence. The sudden activity might force a rethinking of that conventional wisdom. One of the gravest fears emerges when one considers the possibility of an undersea collapse, or worse, a tsunami trigger. If a major fault or plateau were to collapse into itself or shift rapidly, the displaced volume of water could generate a wavefront. Even if the initial anomalies appeared as subtle distortions and ripples, their escalation could, in theory, convert into destructive surface waves. The fact that the event is already producing localized pressure shifts and bottom undulations might hint at a nascent tide of power gathering below the waves. The danger is that most predictive coastal models assume gradual changes, not sudden ones. If this phenomenon advances, coastal communities might be blindsided by waves or surge that arrive faster than warnings can spread. The scale of the disturbance also suggests that it's not a small fault, but a system of faults or a zone of instability. Florida's geologic record is shaped by limestone, karst systems, and layers of sediment that over millennia have shifted, dissolved, and reformed. If multiple subterranean zones are being stressed by sea level rise, groundwater extraction, or shifting tectonic plates, the entire nearshore foundation might be destabilizing. In that scenario, what we're witnessing along the coast might be the first outward signs of a massive rebalancing. The ecological dimension is equally daunting. Even before catastrophic damage arrives, these shifts could release trapped gases or toxins from sediments, stirring up heavy metals, methane, or even noxious compounds. Coral reefs, seagrass beds, and marine ecosystems could suffer sudden, unexplained die-offs. Fisheries might collapse as species flee or perish in zones of turbulence. Plankton blooms, oxygen depletion, and water chemistry disruptions could cascade outward. If marine life flees en masse, coastal food chains collapse, local economies falter, and coastal communities dependent on fishing, tourism, and recreation face cascading hardship. If the phenomenon escalates, the human cost becomes terrifying. Evacuation plans along the east coast of Florida from Jacksonville down through Miami and the Keys rely on warnings of storms or tsunamis. But in this case, by the time warning signals become clear, a wave, or a series of waves, could already be en route. The infrastructure nearest the shore, roads, houses, seawalls, boardwalks, would be most vulnerable. Hospitals, shelters, and emergency services could be overwhelmed by a sudden inundation. Inland areas might be caught off guard as floodwaters race uphill along river canals or drainages. The economic toll would ripple inland. Real estate destroyed, utilities knocked out, supply chains severed for days or weeks, and an entire region thrown into crisis. Moreover, if the anomaly continues or intensifies over days or weeks, the sense of dread will amplify. Residents would be living on edge, unsure whether their properties are safe, unsure whether harboring a boat in port is wiser than evacuating, unsure whether the ocean itself is friend or foe. In that psychological landscape, mass panic, chaos, and irrational decisions proliferate. Evacuation traffic itself could become lethal. The fear is that such an event is not just a natural disaster, but a transformation. Once undersea geology begins to reconfigure in real time, humans may find themselves powerless to stop the consequences. Another worrying vector is that such coastal destabilization could dramatically increase vulnerability during future storms. A coastline that is already shifting cannot absorb waves or storm surges as effectively. Barrier islands might weaken, dunes could collapse, and seawalls might fail under stress. Hurricanes or tropical depressions running ashore could now trigger secondary collapse zones, amplifying their effect in unexpected ways, creating super tsunamis or tidal surges that exceed forecast models. In a worst-case scenario, one tempest could catalyze a chain reaction. The storm strike triggers more coastal collapse, which in turn produces waves that travel outward, compounding the damage. It's also essential to consider the implications beyond Florida. Coastal systems across the world may share hidden vulnerabilities that remain undetected by existing monitoring networks. If something like this can happen unexpectedly on one coast, the same physics may apply elsewhere. California, the Mediterranean, the Indian Ocean, the South China Sea. Our complacent faith in stable coasts might be shattered. Coastal cities built over millennia may face risks they've never anticipated. The Florida event could become a case study in hidden coastal fragility, prompting a re-evaluation of how we monitor and safeguard coastlines worldwide. The timing is also unsettling. Such a sudden, simultaneous disturbance might not be isolated. It might be tied to a broader shift in Earth systems. Changes in sea level, shifts in ocean current patterns, or even distant seismic stresses could be influencing this region. If external stressors such as climate change, warming seas, rising pressure on tectonics are contributing, then the Florida coast might be the symptom, not the cause, of a system-wide shift. We might be witnessing a preview of future coastal fragility under changing planetary conditions. Equally grim is the possibility of misinformation, rumor, and confusion muddying both public perception and response. When normal expectations of calm water fail, people may misinterpret natural warning signs, delay evacuation, or dismiss alarms as false. Local governments may be reluctant to panic populations until clear evidence emerges, yet waiting for certainty might be too late. The lag between anomaly detection and public communication becomes a critical weakness. If authorities cannot act swiftly and decisively, the loss of life and destruction of infrastructure could be catastrophic. Between scientific teams, government agencies, and coastal communities, massive coordination will be required, but the window for action may be short. Sensors need to be deployed, sonar arrays refitted, coastal tilt monitors activated, drone and satellite imaging focused. Yet those efforts themselves may lag the escalating event. The impression creates that coastal defense and early warning systems must evolve beyond storm tracking into real-time geophysical responsiveness. In other words, just as we have tornado and hurricane sensors, we may need coastal integrity sensors that flag undersea shifts before they breach thresholds. At its core, what we are witnessing, the weird activity along the Florida coast, is a warning sign. It suggests that beneath the everyday hum of waves lies a realm of dormant tectonic, geochemical, and hydrodynamic forces capable of abrupt change. It reveals that what seems stable and placid at the surface may mask deep tensions and potential for disruption. In that sense, our biggest fear, the sea turning from a source of life and livelihood into a source of sudden violence, may slip into reality. We must not dismiss this as a freak event or anomaly that passes quickly. The magnitude, scale, and synchrony across the coastline demand serious attention and prompt assumption of worst-case trajectories. If this phenomenon is the first tremor of something much larger, then the Florida coast is offering us a glimpse into a new kind of threat, one that does not rely on storms or meteor trajectories, but emerges from the deep, unseen mechanics of Earth itself. In the silent hours before dawn, when coastline scanners detect nothing obvious, and yet instruments tremble, the sea may be composing its own prelude. Those who live and love the shores must heed the signals, prepare for the unthinkable, and recognize that already the unimaginable might be creeping closer than we thought. The strange phenomenon unfolding along the Florida coast has deepened into a haunting mystery that stretches beyond the visible and into the unknown. Each day that passes without a concrete explanation adds layers of anxiety, speculation, and scientific curiosity. The most unsettling part of the unfolding situation is the silence of the ocean itself. It offers no roar, no quake, no thunderous cue, only a subtle rearrangement of patterns, a quiet defiance of the natural order that once governed these waters. Those who have watched the tides their entire lives are beginning to question their understanding of the sea, wondering if what's happening beneath the surface is rewriting the laws that once seemed immutable. In the days following the initial signs of distortion, coastal residents began noticing further abnormalities. The water color shifted in certain places, not dramatically, but perceptibly. Inlets once turquoise turned slate gray at odd intervals, and shimmering ribbons of darker water stretched like veins across the shallows. Boaters reported that the sea felt heavier, denser somehow, as if currents resisted their movement. Some even described the eerie sensation of their vessels gliding over invisible barriers, thin zones where the water temperature dropped suddenly, or their compasses spun briefly before correcting. Fishermen hauling traps found them disturbed or empty, the bait stripped away as though swept by a mass movement of marine life escaping some invisible disturbance. Dolphins that typically swam close to shore vanished for several days, and seabirds began circling further inland as though seeking safety from an unseen threat offshore. Oceanographers monitoring from regional research facilities became aware of peculiar readings in coastal sensors. Instruments designed to track wave height and sea level variation began logging micro-fluctuations that defied ordinary tidal patterns. These were not the gentle oscillations of lunar tide, but staccato bursts, sharp rises and falls of a few centimeters, happening at irregular intervals. Even more perplexing was that these pulses occurred almost in harmony across distant points along the coast, suggesting a connected cause. When graphed, the data resembled a heartbeat, an ocean pulsing with a rhythm that no known natural mechanism could explain. Some analysts speculated that a large-scale resonance was occurring, as though pressure waves were bouncing between the continental shelf and the ocean surface in perfect synchronization. Such resonance could theoretically be triggered by shifts in deep subsurface cavities, releasing bursts of trapped energy into the water column. Local divers exploring near the coral ridges found their compasses unreliable, turning erratically within certain zones. They described clouds of particulate matter suspended in otherwise clear water, as though sediment had been churned up from below without any visible disturbance. In some places, thermal layers felt inverted, warm water sitting below cooler strata. That inversion baffled marine scientists since it suggested a reversal of normal convection patterns. It was as if the ocean floor itself had begun exhaling warmth, pushing heat upward instead of absorbing it. The divers also reported an unsettling acoustic phenomenon, faint, low-frequency vibrations audible even through the breathing apparatus. The sound wasn't constant, but seemed to pulse like a deep bass that one could feel more than hear. Some likened it to the growl of distant thunder, others to the resonance of machinery hidden beneath the sea. Scientists who examined spectrographic data from underwater microphones confirmed these low-frequency hums were real. The signal propagated across hundreds of miles, with no identifiable source point. Its amplitude rose and fell in a slow pattern, almost cyclical, peaking roughly every few hours before fading again. While nature produces a variety of subsonic tones, from volcanic tremors to whale calls, this frequency matched none of them. It lay in a spectral gap where no known natural acoustic sources typically exist. The implications were staggering. Either an unknown geological process was generating it, or something artificial lay far beneath the waves, emitting energy that interacted with the environment in ways beyond current understanding. As the enigma deepened, meteorologists and atmospheric scientists began detecting atmospheric anomalies directly above the zones of disturbance. Weather balloons recorded faint electrical gradients higher than normal, and small localized pressure dips formed over calm seas. These anomalies didn't produce storms or lightning. They hovered like invisible domes of static imbalance. Aircraft passing through these regions experienced brief turbulence, even in clear skies, as if invisible eddies of charged air spiraled upward from the ocean below. The connection between the oceanic disturbances and atmospheric behavior remained speculative, but it hinted at a coupling between Earth and sky, a vertical column of altered energy extending from seabed to stratosphere. By this point, even hardened skeptics had to acknowledge that something profound was unfolding. Universities across the United States and Europe redirected oceanographic satellites toward the region. Thermal imaging revealed a faint halo of elevated temperature stretching along the coast, barely perceptible but continuous, almost like an artery glowing beneath the water's surface. Analysts debated whether this warmth represented geothermal upwelling, methane release, or friction from subcrustal movement. None of the models fit neatly. The heat pattern was too linear, too uniform, stretching hundreds of miles. It did not match the random outgassing one would expect from geological vents, nor did it correspond to ocean currents that could explain such distribution. There's a growing theory among certain researchers that what's happening might represent an emergent phenomenon, a convergence of multiple factors reaching a tipping point. Rising sea levels, increased ocean salinity, and shifts in groundwater flow might be destabilizing Florida's unique limestone foundation. Beneath the coastline lies an immense aquifer system riddled with sinkholes, caves, and channels that extend beneath the seafloor. If saline water intrusion has altered pressure balance within these caverns, the result could be structural collapse or implosion events occurring out of sight. Those collapses could, in turn, release gas, displace sediment, and trigger a cascade of oscillations that travel outward through the water column. The coast could be literally breathing, its subterranean lungs inflating and deflating as the pressures equalize. Such a mechanism might explain the rhythmic pulses detected by coastal sensors. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the strange activity along the Florida coast recently? We want to hear from you. Thank you for watching, and see you next time.